Welcome to the Wireless LAN News Desk for April 19th, 2019. My name is Tom Carpenter. I'm the CTO at CWNP, and we're continuing our investigation into artificial intelligence, machine learning, deep learning, and all of the rest of terms you might see in relation to wireless networking. Now, the first thing I want to do this week is take a look at probably one of the best overview white papers out there from a Wi-Fi vendor related to artificial intelligence in Wi-Fi, and that's by Mist Systems. The white paper is titled Bringing Artificial Intelligence to Wireless Networking, the Journey to a Virtual Wireless Assistant. Now, when we look through this paper, if you read it in detail, you're going to find some specific things of interest. First of all, you'll notice that it's very focused. We're not talking about a general computing machine or what was originally termed a thinking machine for several decades. The reality is that we're talking about a specific use case implementation of artificial intelligence. You might call it a constrained domain AI or a limited domain AI, but the point is that it's focused on a specific kind of problem. In this case, we're focusing in on wireless or networking problems that might be solved through artificial intelligence. So what does that really mean? Well, if we back up our thinking related to artificial intelligence, one subset of this category over the years that has been discussed is called expert systems. Expert systems were discussed in the 1950s and 60s and 70s and 80s. This is nothing new. The concept of an expert system is to say, I'm going to build a solution that within a specific domain of expertise can provide advice or suggestions from data provided. Now, some of the earliest systems were simply a sequence of questions. For example, it might be, what is one of your primary symptoms if this was a medical expert system? And you put in a primary symptom and it then asks you, do you also have this other symptom? In other words, once you put in one symptom, it may have a list of 30 different problems that exhibit that system. But among those 30 problems, there are some unique subsections that have one or two specific symptoms. So if they can find out if you have that other symptom, then they narrow the field from those 30 problems to a few problems. Then they'll ask about another symptom and narrow it even further. And then they'll say, this may be the problem. So the point is there are simply some branching trees of logic that narrow it down to an end node that is the most likely problem the person is facing based on their symptoms. That's, in general, an expert system. Of course, there are more complex algorithms, but I'm summarizing it for you. So the concept then is that an expert system is able to have a wealth of knowledge about a specific domain and then look at data related to that domain to determine where there might be problems or issues, where there might be opportunities for improvement, where there might be problems that are going to occur in the future based on how things were a week ago, this week, and so forth. So that's the general concept of an expert system. And really what we're dealing with in wireless AI is Wi-Fi expert systems. That is, they have limited knowledge to that domain. What I mean by that then in general is we didn't take a generally knowledgeable artificial intelligence unit, dump it into the system and say, now figure out how Wi-Fi works all on your own. No, we programmed it for how Wi-Fi should work and symptoms of bad behavior and so forth. It didn't learn what is a bad thing or what is a good thing necessarily, but it was programmed with that. Now, it might learn about your environment over time, but it doesn't learn what's good or bad. It's told what's good or bad, and it must be from many different ways. It could be that you input your expectations of the system, and therefore when it's not meeting those expectations, it's bad, or it could be that experts have provided baselines or guidelines for what is a well-performing environment. Either way, it was told what to look for in possibly mountains of data so that it could give you recommendations. So think of it like someone who already knows what to look for in Wi-Fi, now manually going through all of your data to try to give you advice and then charging you $250 or $500 an hour to do that work for you. With artificial intelligence, you have a program or a set of programs that are doing that for you, okay? So that's an overgeneralization, but to give you a general idea of what's behind all of this AI stuff in Wi-Fi. They call it a virtual assistant at MIST because it's obviously not a real assistant, it's virtual, right? So it is a conceptual assistant that is there running in the processing of the system to give you information about your environment. So this is a general white paper on AI, and they use the term AI, machine learning, things like that throughout this paper. So for them, they directly call it that. But now take what they're describing here. So they're describing the ability to look at lots of data, see what's good, what's bad, look at lots of data from the past and the present, and see where things are going and make predictions. This is the kind of stuff they're saying they do, right? If we take a look at Cisco Meraki for Meraki Insight, you'll notice Meraki Insight helps IT administrators optimize the end user experience, significantly reducing the time it takes to isolate network or application problems that lie beyond the LAN and create happy, productive users. We can see it incorporates information from the end user through to an app server or some destination, and where there might be problems on the network. In this case, there appears to be a WAN or internet problem. So the key is that Meraki Insight is going to look at what's going on your network and give you insight into what might be the point of problem. So you don't have to manually test each node in the route between the end user and the end destination. What do you know? That sounds like we're looking at a lot of data, having intelligence about what's right and wrong, and then determining where there might be a problem and letting someone know. Interestingly, that technically could be defined as artificial intelligence, because that's what it is. Remember, I defined last week for you that artificial intelligence is a system appearing to have intelligence. So if you look at the actions of the system and say it looks intelligent, then artificial intelligence is involved, whether the people call it that or not. There's no question this Meraki Insight concept could be termed artificial intelligence, though you won't find the term artificial intelligence or machine learning anywhere on this page. Now, the next thing, an interesting article at eCampus News about Dartmouth College and their implementation of a Wi-Fi solution that uses artificial intelligence. You will notice if you go down far enough in this article that indeed they are using Mist Wireless as their AI solution. But I found this to be interesting, even though this article is a little bit older now, because of this last paragraph. Dartmouth may seem unnatural to be an early adopter of an AI-driven campus wireless LAN. After all, the field of AI research was born at a workshop organized by a Dartmouth professor on the campus in 1956. So, interesting that they mentioned that, and of course, it is true. There was what was called the Dartmouth Workshop, and you can see information about that at Wikipedia. It goes into the details of who attended, how long it lasted, about 6 to 8 weeks, and what kind of things they discussed. Of great interest, as you can find online, the actual notes of Ray Solomanoff, and this is just his summary. He has dozens of pages of individual daily notes from this event at Dartmouth about artificial intelligence. You're going to see throughout his notes the acronym TM. You see it right here. It says these guys may eventually invent TM. TM stands for thinking machine. Going into this Dartmouth workshop, thinking machine was probably the most common term used instead of artificial intelligence. One of the founders of this workshop, John McCarthy, actually coined the phrase artificial intelligence and made the request to have an artificial intelligence workshop, but going into it, no one was used to using that term. And so thinking machine is the common term that was used throughout that particular workshop, as well as some other terms, computational thinking, etc., that were used out of that era. So the interesting thing that I found in the notes by this individual is that these guys may eventually invent a thinking machine, but look at the clarifying clause. Simply by working more and more interesting special problems. And then he gives names of people he thinks are best candidates and who is actually just a question mark in their ability to do it. But the point is that they may invent a thinking machine, okay, our term today, they may invent artificial intelligence simply by working more and more interesting special problems. So this is all the way back in the 1950s that they were saying that we really need to focus on special problems. We don't have the computational power. We don't have the wealth of background research yet to build a generalized thinking machine. Well, guess what? We are still today, all of these years later, at the point where the application of AI consistently is working more and more interesting special problems. So we're talking here about AI related to Wi-Fi, a special problem that AI can deal with. And we're going to continue having to deal with special problems with AI. Because what did we learn last week? AI is nothing more than the implementation of one or more algorithms, maybe complex algorithms, but they are algorithms that work against data in order to make decisions, recommendations, etc. So therefore, what we continue to see is the need to do specialized AI, not generalized AI. A general thinking intelligent machine that can learn on its own, that is to say, a machine that knows nothing about, let's say, physics, can learn, understand, comprehend, and implement systems that are based on physics, that kind of a system, to be able to learn that knowledge on its own, we are decades, centuries, possibly forever away from that kind of system. So instead, we have specialized systems in artificial intelligence, and Wi-Fi is such a system. So as long as we're clear what we're talking about when we say artificial intelligence in Wi-Fi, then I'm fine with it. I don't like the general colloquial understanding of artificial intelligence that says, oh, so we've just put a robot into our Wi-Fi network that is smart and intelligent like a human and able to learn anything, and therefore now it will learn Wi-Fi better than any human could, and it will make the best decisions for Wi-Fi for us. No, 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 not even close. That is not what AI is. It's a special use case of applied intelligence through programmatic logic that an actual intelligent person puts in. If the programmer who builds Wi-Fi AI doesn't know anything about AI and doesn't get input from someone who's an expert, or rather doesn't know anything about Wi-Fi and doesn't get input from someone who's an expert in Wi-Fi, that system is going to be artificial ignorance, not artificial intelligence. And sadly, maybe I'm coining a phrase here, I don't know, but a lot of what is called AI is actually artificial ignorance and not artificial intelligence. Okay, well, let's wrap things up with a little bit of fun. So here at Microsoft AI, where they drive innovation, I thought you might like to know that yes, AI is being used in some very important areas. And one of those important areas is the pursuit of better beer. So Carlsberg is leading the way in bringing AI to one of the world's oldest industries. They're using what they call the Beer Fingerprinting Project, which uses advanced AI sensors and analytics to measure and predict new beer flavors. That's right. We are handing over even the creation of beer to artificial intelligence. Well, that's all I have for the Wireless LAN News Desk this week. Thank you very much for joining me, and I'll see you next week on the Wireless LAN News Desk.